Hey everyone, this is a review as requested for solving using square roots. So we're going to start with some basic examples and move to some more difficult ones as we go through. We're going to start with kind of the most basic, x squared minus 64 equals 0. So the key here is that we have an x squared term, a constant term, and we have no term with an x. If we had a term with just an x, we couldn't use the square root method because that's not a perfect square. X squared terms tend to be perfect squares. Constants, we can pull perfect squares out. Some are perfect squares, some of them we can just leave as simplified radicals. Okay, so no terms with an x. That is when we use the square root method. Notice we have two terms here, neither one has an x. And as we move through these problems, you'll see that no terms are going to just have a pure x. If there's an x, it's probably in a quantity being squared. So let's start with this one. We want to isolate the x squared, so we'll add 64 over. We have x squared equals 64. From here, we take the square root of both sides, and we get x equals plus or minus 8. Okay? The reason it's plus or minus is because negative 8 squared equals 64, as well as positive 8 squared also equaling 64. Plus, it is a quadratics, we expect two roots, and here we've provided ourselves with two roots, x equals plus or minus 8. So like I said, that's a very basic example. Here's another fairly basic one. X squared minus 18 equals 0. Again, isolate the x squared. X squared equals 18. Take the square root. Now 18 is not a perfect square. But if you think back to simplifying radicals, we know that there's a radical, or a square root inside of this radical that we can pull out. So we're going to say x squared, at this point actually we get x, equals plus or minus the square root of 9 times the square root of 2. Since 9 is the biggest perfect square that goes into 18. Always make sure you're pulling out the biggest perfect square. If this term here had a perfect square left inside of it, we know we didn't pull out the biggest square root here. The biggest perfect square there. So we get x equals square root of 9 is 3, plus or minus 3, radical 2. And again, x squared and constant, no x term. So that's another fairly basic example. How about this one? 5x squared minus 125 equals 0. Now, we want to make sure that our x squared is alone, and it's certainly not. Right now it has a constant with it and it has a number next to it. So we have a couple of options here. First, I'm going to start by adding 125 over. 5x squared equals 125. Now I can divide both sides by 5. You could have just as easily taken out a GCF to start. Doesn't matter to me. It's just, this is keeping consistent with what we have been doing by moving things away from the x squared term. So if you divide by 5, you'll get x squared equals 25. Now you can take the square root and get x equals plus or minus 5. Okay? So that's a fairly simple example where you could have either started by taking out the GCF and added the 25 over and taking the square root, or you could simply add over and then divide by 5. Either way would come out the exact same. That 5 is a constant out there, is just the factor that puts it up to here. Alright, so how about this one? Negative 3 minus x squared equals 9. So, add 3 over. Negative x squared equals 12. Now, we've got to get x squared alone. We can't have a negative x squared. That's not alone. This is a negative 1 that needs to be divided out. X squared equals negative 12. If we take our square root here, we get a radical into the denominator, and we can say no real solutions. So anytime you have a negative under the radical, no real solutions would be the response. Okay, we don't know how to do that yet. That's something for Algebra 2. This last one seemed to give a lot of people issues on our quiz that we had, and I would expect problems of this difficulty on the test. So we're looking at x minus 2 squared minus 3 equals 51. The issue that I saw was most of the time people tried to expand this and then factor, and if you wanted to do that, you'd have to use the zero factor property and pull the 51 over, and most people didn't do that. Not to mention, a lot of people thought that this would be x squared plus 4. It's not. If you were to do this out, x minus 2 squared would be x minus 2 times x minus 2, which would end up being a double distribution. X squared minus 2x plus 4 would be x squared minus 4x plus 4. Like when you think about completing the square, we're never looking at just two terms when we come out with the x minus 2 squared part of it, or x plus 2 part of it, depending on what our b over 2 is. So just remember that if it's binomial squared, you actually have to write it twice and do the double distribution. So I don't want to do it that way because that's a lot more work. So we'll do it the easy way. The easiest way to do this one is to add the 3 over first. Right? Try and get the x squared term alone. I know it says that there's just an x here, but it's squared, right? Because if we were to do out all that work, we'd end up with an x squared somewhere. If you leave it as this is actually a perfect square. So x minus 2 squared equals 54. And now we can just take the square root of both sides. We can delete these inverse operations, right? They'll cancel each other out. So we could say x minus 2 equals plus or minus the square root of 54. Now that can be simplified. I know we can take a 9 out of that. We'll be left with a 6. Right, all I did was simplify my radical. Now I just have to add the 2 over. And I get x equals 2 plus or minus 3 radical 6. And that's it. And that's about as far as it gets for the square root property, because we only have so many options when we only have the x squared term and a constant. Okay?